Okay, so here we're told a motor in a blender has a single coil with 500 turns and an area of 20 square centimeters. The coil sits in a magnetic field of 0.1 teslas. If the coil carries 1 amp, at what angle does it experience a torque of 0.05 Newton meters? Okay, so here for our answer we're going to be using our torque coil formula, but now we're going to be solving it for theta. So we have torque on a coil is equal to N times current times area times field times sine of theta. Divide both sides by NIAB. N times I times A times B times I times A times B. This cancels all of these. This tells us sine theta is equal to torque on the coil divided by NIAB. This is really just an exercise in mathematics to see how comfortable you are in doing this. To get the theta on its own, we need to apply the arc sine. So we get theta is equal to arc sine of torque of the coil divided by N times current times A times B. For anyone who's not familiar with the arc sine notation, on your calculator this is the sine minus 1. Sometimes this is called inverse sine. We really shouldn't call it inverse sine. Inverse sine should really be 1 over sine. But arc sine is one of the names given to it, and it's the name I'm going to be using. So now we need to work out all the variables inside the arc sine. Well, we know the torque on the coil has to be 0.5. So we're told in the question. So to get this theta, we're going to have arc sine of 0.05 divided by N, which is 500. So we're told it's a single coil, but there's 500 loops, so N is 500. The current we're told is 1 amp, so that's 1. The area we're told is 20 centimeters squared. So 20 centimeters squared needs to be converted to square meters. This ends up being 0.002 meters squared. 0.002, and then we have to multiply this by the field, which is 0.1. So you plug this all in, evaluate this, and this should come out as theta equals 30 degrees. So this is the answer, and so this is the angle between the surface normal and the field. So if we were actually drawing this diagram, if we've got our north over here and then we've got our south over here, this is the magnetic field direction. The coil would be sort of like this, so that this angle was about 30, or it would be over here like this, so that the angle was 30 over here, right? Because mathematically these are symmetrical in a certain sense, right? We could get either of these depending on how we oriented our calculations.